Lesson 2, interval notation. Okay, so on the next slide, I have some definitions for you. So with this notation of interval notation, we use a parenthesis anytime we see a point that is a whole, or if we use a number line. For example, I have a number line and I say 5, and I'm saying x is less than 5. If I had an open hole at 5 and went to the left, for my interval notation, I would use the lowest value first, negative infinity, all the way up to 5, and I would have parentheses around both sides. We call this the exclusive value. We exclude the value of 5 and negative infinity because these are non-touchable values. You will always use a parenthesis for infinity, plus or minus, whether it's positive or negative, and you'll always use parentheses for increasing and decreasing. Now, if we had something like x was greater than or equal to 7, on our number line, we would put a 7, closed hole, go to the right, and we would indicate in interval notation the lowest value of 7 going to infinity. Notice 7 has a bracket where infinity has a parenthesis. We include the number of 7. I can touch or graph that point, but also notice for infinity, just like I said on the last column, you always use parentheses. So now you had some worksheet to do. Here are the answers to that worksheet. You might notice that there's inequality notation, there's interval notation, and then there's graphs. For all of my graphs, I just use the coordinates or the values that they have indicated. I don't need to continue counting. This is 1 through 7. Pause if you need to. Here are the answers for 8 through 12. Again, pause if you need to. I'm going to continue going. So when I give you a graph that's distinct, and in this case, this is a piecewise function on a certain domain, you are being asked in this case to write all of your answers in interval notation for the rest of this activity. So if I was asking you for the domain of g of x, I'm asking for what x values is this graph graphed? Well, I start here. This is the first x value. And then as I go to the left, there are points all the way until I get to this x value. So I could say from -6 to 6, there are points on the x's. Because there are solid dots at each of these values of x, I'm going to include both of those statements of -6 to 6. In terms of my range is going up and down. So I need to go, okay, what's the lowest point on the graph? The lowest point on the graph is here at -3. I'm including it because, again, it's graphed, it's a touchable point. And then the highest point, well, you could either say is over here at 3, but also over here at 3. So you could say it's going from -3 to 3. Again, include the values. Okay, continuing with that same g of x function, the next question says, where is g of x increasing? So when it asks us this question, the hint we want to do is we want to look for positive slope. So I'm going to highlight all of the sections of this graph where I see positive slopes. I see positive slopes happening from here to here, as well as from here to here. Now, the question is, on what x values is this positive slope occurring? Well, I'm going to now also bring this dot to 6 and bring this endpoint to -2 so I can understand that the domain is happening from the values of -6 to -2. Now, because it's increasing, like I told you at the beginning, anytime increasing or decreasing is asked of you, you always use parentheses. Now, because we have two sections of this happening, just like on our number line situation we did at the beginning, we're going to use the statement of or, which is a U. And again, I'm asking the domain of what it's happening. So that was from when x is 2 to when x is 6, parentheses around both. Okay, question number 4 says, where is g of x decreasing? So just like the last one, we're going to look for slope, but this one, because we're decreasing, we're looking for negative slope. Now, the negative slope, again, I'm going to highlight, so I'm going to change my color. I'm going to highlight this guy. I have negative slopes from here to here. Again, the question is asking at what x values is this occurring? So my final answer would have been from -2 to 2. Again, since it's decreasing or increasing, we always use parentheses. Number 5, where is g of x positive? Another way they could write this statement is they could say g of x is greater than 0. That's a shorthand of this question. So where are the y values greater than 0, and list your final answer on the domain of x's. So again, I'm getting a different highlighter this time, and I'm going to mark everywhere on this graph where the y values are positive. That would be from here to these 2 segments. My final answer is going to be the x values. So we have -4 all the way to 1, uninclusive, or from 3 to 6. Now here's the interesting part. When you look at the y value of x is 6, you would say the coordinate is 6, 3. Because that x value of 6 has a positive number of 3, and it makes that inequality right above that coordinate statement a true statement, we put brackets around the 6 because that is a positive y value. When x was -4, when x was 1, and when x was 3, those y values are 0. 0 is not greater than 0, so we do not include those points. Okay, number 6. Similarly, we're going to ask you another question. Where is g of x negative? So again, the way it might be worded in shorthand is g of x is less than 0 on what domain? So again, I'm going to highlight all the parts of the graph that are under the x-axis, or where the y values would be negative. And then I have to go, well, what's the domain of that? Where are the x's that make those highlighters true? Well, it starts at -6, it goes to -4, or it goes from 1 to 3. Now, at the coordinates of when x is 3, when x is 1, and when x is -4, those y values are 0. 0 plugged into that inequality statement. 0 is not less than 0, therefore we use parentheses. The y value of when x is -6 is a negative number, so we bracket that -6. Okay, now we're going to get into function notation with numbers. So the first question, 7a, says, what's g of 0? Remember, 0 is the input value that we're using, so we're asking you to go, when x is 0, find that y value that makes it true. So on my graph, I go to when x is 0, find the y value, and you might say 1. Yes, you can write your answer as a coordinate 0, 1, but I would leave it as g of 0 equals 1. 7b says, where's g of x equal to 0? What that question is actually saying is what x values exist when the y values are 0. So I'm looking for when y is 0. Well, that happens 3 times on our graph. Y values are 0 3 times. So our answer for 7b is going to be in solution set notation, and I'm going to list them from least to greatest. -4, 1, 3, close the set notation. That is the x values when y is 0. Last but not least, the final question I have for you is g of 5. To do g of 5, what you want to do first is take the inside and look at that independently. So I want you to find what g of 5 is. So the first step of doing this problem you're going to just find what is g of 5. What does that equal? Well, that says when the input is 5, what is the y value? So when I go to the input of 5, I see that the y value here on this coordinate is 2. So I can say that g of 5 is equal to 2. That means that I can take the original statement of what they gave me, and I could say, well, then can't I replace the middle part, g of 5, with what I found, which was 2? And the answer is yes. So now the question is, what's g of 2? Well, g of 2 is -1. So I can say the answer to g of 5 is -1. Now, if I did that again, if I made a different question, if I said, number 9, what is g of 4? Well, first I would have to find g of 4. So once I have g of 4, which is here, 1, I can rewrite this as g of 1, and then I can go to when x is 1, and I can find the y value of 0. So g of 4 is 0. Folks, that's a lesson at its finest. Have a great day.